Hello and welcome to Geekatplay Studio Tutorials. In these tutorials, I want to look on a linear workflow. Let's first understand what does a linear workflow mean. It seems like very popular word buzz going around, and let's see why this is very popular. But before we go inside the view and see how we can do these adjustments inside, I want to overall look at this first part and understand what does it mean linear. So let's say right here we have it our power and we have it our luminosity. When we have it output, normally we have it for every point of the power, we have an equal type of luminosity produce. So in a real world, we have it this linear kind of going line. So it's meaning every time when we have it light increasing power, we have it lights producing equally. So imagine right here we have it black, and right here we have it white. So it's meaning every time when we increase, we have it smooth line going of the power it produce. The one thing in a visual art what we're working, we also try to make world around us look realistic. It doesn't necessarily mean it is how work exists. It's our perception of the world is look realistic. For example, every object is sharp. We don't have it objects that fuzzy, they all have it hard lines, but when we look with our eyes and due to our focusing, the objects some appear to out of focus, so they're fuzzy. So depth of field, we're also simulating in our images. Even in the real world, not all of the images become fuzzy or not fuzzy, except maybe bunnies or kitties if you like it, but overall, everything have a sharp edge. So what's happening? We're simulating our eyes to make world look realistic in our artwork. So same right here, even all object. What's happening next when we start using the electronic device or monitors? Due to some problems with the um, electronic limitations with how each pixel is producing, will absorbing power and producing luminosity, and in some cases with the manufacturing of the monitors that try increase contrast, what's happening, the power doesn't produce properly, so we start having this kind of curve. What is meaning? Now we start, for every power we spend, we produce less luminosity, and next we're going way high luminosity, so we kind of shrinking the areas with higher details. So what's happening? Let me show you visually what's happened with this. Let's say right here is a normal gradient of the gray that's going. Again, I'm displaying this as an example on this monitor. So we have a dark area and we have a very nice linear going up gradients. So we have details in every options. What's happened next with monitors when they take this gradient, they're converting more towards this with compressing those areas or overlay with highlights. With the highlights, we don't see that much different, and reason why, because our eyes, they build this way, we can see quite a bit on the dark area details. We do not accept so much on highlights. And as example of this, when you take HDRI images, for example, of the sky, here's example, you can see how much clouds certainly pop up that originally you don't see with your eye. The reason is why, because again, our eye is not that sensitive to the lights, to the highlights. It's more sensitive to the grays and dark areas. It's how we absorb by our lights. So by this is more natural toned down HDRI, and you can see a lot of skies. But when I took these pictures, the image was actually, I don't see any of those clouds. I just saw the clouds right here because my eye was ignoring the highlights here. So let's go back to in this image. So when we start creating image, we don't see so much on the image problem with highlights, but we see over contrast on this case. So let's see right here, example. This is like we render very fast in view, and you can see highlights, they're okay, but right here we start having crush black and dark, very contrast image. Again, this is look not very realistic. With the what we need to do, we need to apply some compensation for our monitors. Another case, if we have a line going right here, we need actually overcompensate. This is one. Let's say this is our reference one. This is what's happened to our monitors in other ones when we preview. To compensate this, we actually need to go over or put it 2.2, which is define the gamma, which is overcompensating. And with monitors, both of those, the error in monitor in our overcompensation will give it us this black, the perfect linear growth in our power per edge illumination. That does have some problems when we start overcompensating, and it's again because based on us. Even this picture look pleasant and nice, contrasted, but when we start applying gamma correction, we start having more details in the gray, but it's look washed out. So it's having some problems with the coloring. So we need to apply properly, remove wash out from the colors, and also apply some properly blacks and other stuff. It's have a little bit work need to be done. Again, this was done just normal in a view with no compensation applied gamma correction, and this one was applied 2.2. Again, we have it better on a grays, but we start its picture look very washed out. So what are we going to do? We're going inside the view application, and we'll see how in the new 8.5 will give us easy tools now to correct gamma by using linear workflow. Again, in linear it's referring because we have it nice, not curves, doesn't anything. It will give it us properly per power luminosity output. Again, this is just overview what we're going to do, and at this point we can go inside the view, and we will start looking inside the view on options that was added at 8.5.